Hello everyone, welcome back to my YouTube channel. I am Maunika from Sri Venkateswara College of Engineering, Department Basic Science Program, Computer Science and Engineering, Semester First Year, Course Title Waste Management, Topic Disposal Options and Selection Criteria. Introduction. We observe heaps of garbage lying along the road while passing through a highway. Open dumping is the most common method of waste disposal in India. These dumps are subjected to open burning, which can release toxic fumes and smokes. There have also been instances where enough heat has been generated to trigger a spontaneous combustion. Sometimes waste are illegally dumped into rivers and canals or used to fill land depressions without proper consultations. These practices cause a lot of problems in long run. This can range from degradation of soil quality to leaching toxic chemicals into underground water sources. Therefore, to prevent such scenarios, proper waste disposal method should be adopted. Methods of waste disposal. Garbage accumulation has never been much of a concern in past, but due to globalization and industrialization, there is a need for a more efficient waste disposal method. Following are some of the methods that are used today. First, landfill. In this process, the waste that cannot be reused or recycled are separated out and spread as a thin layer in low-lying areas across a city. A layer of soil is added after each layer of garbage. However, once this process complete, the area is declared unfit for construction of building for next 20 years. Instead, it can be used as a playground or a park. Incineration. Incineration is the process of controlled combustion of garbage to reduce it to a incombustible matter such as ash and waste gas. The exhaust gas from this process may be toxic, hence it is treated before being released into the environment. This process reduces the volume of waste by 90% and is considered as one of the most hygienic methods of waste disposal. In some cases, the heat generated is used to produce electricity. Some consider this process not quite environmentally friendly due to generation of greenhouse gases such as carbon dioxide and carbon monoxide. Waste compaction. The waste materials such as cans and plastic bottles are compacted into blocks and sent for recycling. This process prevents the oxidation of metals and reduces airspace need, thus making transportation and positioning easy. Vermicompositing. Vermicompositing is the process of using worms for degradation of organic matter into nutrient-rich manure. Worms consume and digest the organic matter. The byproduct of digestion, which are excreted out by a worms, make the soil nutrient-rich, thus enhancing the growth of bacteria and fungi. It is also far more effective than traditional compositing. Biogas generation. Biodegradable waste such as food items, animal waste, or organic industrial waste from food packing industries are sent to biodegradation plants. In biodegradation plants, they are converted to biogas by degradation with the help of bacteria, fungi, or other microbes. Here, the organic matter serves as a food for microorganisms. The degradation can happen aerobically with oxygen or anaerobically without oxygen. Biogas is generated as a result of this process, which is used as a fuel, and the residue is used as a manure. Compositing. All organic materials decompose with time. Food scraps, yard waste, etc. make up for one of the major organic waste we throw every day. The process of compositing starts with this organic waste being buried under the layers of soil and then are left to decay under the action of microorganisms such as bacteria and fungi. This results in the formation of nutrition rich manure. Also, this process ensures that the nutrition are replenished in the soil. Besides enriching the soil, compositing also increases the water retention capacity. In agriculture, it is the best alternative to chemical fertilizers. Selection criteria. With the help of proper frameworks and sub-frameworks, we can assess the effectiveness of each of the waste disposal options. While a framework represents an aid to decision making and helps to ensure the key issues are considered, and a sub-framework explains how and why the necessary information should be obtained. A framework contains a list of issues and questions pertaining to technical, institutional, financial, social, and environmental features of a waste disposal system to assess the capacity of a disposal option to meet the requirements. Criteria to select waste collection system: efficiency, effectiveness, equity, reliability, safety and environmental impact. We will discuss one by one from next slide. Efficiency. Efficiency is the ratio of work performed by a machine or in a process to the total energy expended or heat consumed. Efficiency refers to how close we can get to a particular outcome of a given input with as much as less wastage as possible. Efficiency is the ability to minimize wasting materials, efforts, energy and time in performing something or producing the desired result. Effectiveness. Effective waste management involves the practice of 7R: refuse, reduce, reuse, repair, repurpose, recycle, and recover. Among these 7Rs, the first two, refuse and reduce, relate to non creation of waste by refusing to buy non essential products and by reducing consumption. The next two, reuse and repair, refers to increasing the usage of existing product with or without substitution of certain parts of the product. Repurpose and recycle involves maximum usage of the material used in the product, and recover is the least preferred and least efficient waste management practice involving recovery of embedded energy in waste material. Equity. In waste management, social equity means ensuring that all people have access to safe, reliable, and affordable waste services and that they are not disproportionately exposed to environment and health risk from waste generation, collection, transport, treatment, and disposal. Reliability. Reliability is defined as the probability that a product, system, or a service will perform its intended function adequately for a specified period of time or will operate in a defined environment without failure. Safety and environmental impact. Environmental, reducing or eliminating adverse impacts on environment through reducing, reusing, recycling, and minimizing resource extraction can be result in improved air and water quality and help in reduction of greenhouse gas emissions. Images of criteria to select waste collection system: equity, reliability, safety measures. Thank you. Don't forget to like, share, and subscribe my YouTube channel.